Okay, it's been a while since I made the first bit of my video reply, but I just watching your second video now, and you're talking about my hand moving potential infinity problem, and you say that I was talking about a potential infinity, which of course I was. What I think you fail to understand here is that the definition of an actual infinity. It's a strictly mathematical thing, and that's all it is. All an actual infinity is a set containing an infinite number of things, a potentially infinite number of things, such as like the real numbers is the example always thrown up. 1, 2, 3, 4. The fact that no matter where I am, I can always just add a single number, add one single 1 to whatever I am and continue. That means I'm potentially infinite. I could potentially do it forever. Now that is your potential infinite, and that's not a problem. But I can also say, well, these things 1, 2, 3, 4, 5, they're all rational numbers. I'm sorry, they're all natural numbers. And no matter how many of them there are, I can just say, okay, all of them are sort of the same, and I can group them in a set. I can put my little set notation brackets around them, and there you have a set of an infinite thing. And that's what's called an actual infinity. It's that set itself. And the word is used to describe only a set, because trying to use it to describe anything else, if anything physical, for example, is futile, because it's obviously, well, yeah, it's a word to describe a set and not a thing. It's a mathematical thing. It's really just instead of having to say all the natural numbers, I want to do this to them, but then I want to do all this to the complex numbers. Instead of saying that, you can say I want to do this to the set of natural numbers and this to the set of imaginary numbers, and that's pretty much all the difference is. Now the infinities that we think about, any infinity we think about is always a potential infinity. Okay, I just wanted to say that. I'll keep watching the video and see what else I decide to chime in with. Okay, I thought I just heard you say that if we continue to chop down the distance between 2 points, we will end up with a finite number of points to traverse, which is why we can actually traverse it. Well, I'm not sure if you meant to contradict yourself there, but that second statement you made is obviously false, because there's a potential infinity of points between our fingers. Now, the only reason that we can move our hand is because, as what I was talking about in an earlier video, I think, about you can't really use the word infinity to describe a number of things. You can't say I have infinitely many apples, because it makes no sense, because that's not what the word infinity is meant to describe. The word infinity itself, or the best way I define it, to people who ask, or to people who I think would want to know, is it's when we say infinity, what we mean is we're referring to not a thing, not a number of things. We're referring to a procedure that we can do forever. That procedure we call infinite, such as adding 1 to 1 to 1 to 1. We can do that forever. That's the procedure, that adding 1 to 1 to 1. We can do that forever. And that's what we call infinity, or potential infinity. Now, when I say, okay, let's say I move my hand infinitely many of these infinitesimal little spaces, my hand moves through them when I move my hand. Now we can say that all those little infinitesimal movements, they all share something in common. They're all describing my hand moving from here to here. So if we want to talk about my hand moving from here to here, we can talk about that as an actual infinity, because it's composed of an infinite number of little, progressively smaller steps. And there's no problem with that at all. it's an actual infinity right there. It's a set of all the little incremental things that I did. Yeah, and so it'd be really good if, when you, especially in this Kalam cosmological argument type setting, if you just think of infinity as a procedure, because that's really what it is. It's a procedure that we can do forever. I mean, a procedure that we can't do forever, such as, you know, walk. I could say I could take one step, I could take another step, I could take another step, another step, but eventually I'm going to die, right? So you can't call that procedure infinite. Counting, yeah, no problems. You can always add 1 to 1, so that is an infinite procedure. Well, that is an infinite thing. You know, the natural numbers are infinite. What that statement means is we can continue to do this procedure forever. Okay, I'll just, yep, that's enough of that little mini thingy-majiggy. Okay, just another little comment there. You said if you translate an actual infinite number of things, that's where the logic breaks down, right there. Not down the line, and you know, I could lead to whatever conclusion, and it would be ridiculous, because the problem lies in that statement there. If we translate the mathematical term actual infinity without knowing the difference at 100%, then that's where the problem is. When you say an actual infinite number of things, and then that's your starting statement to talk about what you're going to talk about, that's the problem right there. An actual infinite number of things is not possible, of course. A potentially infinite number of things is fine. An actual number of infinite things, no. Sorry. Okay, just watch a bit more. Sorry, I feel like I'm interrupting your video. I like Hilbert's quote there. I've never heard that before. He was, what was it? Infinity neither exists in nature, nor is the basis for any rational thought. Well, I think he must have, to say something like that, being the mathematician he was, he must have said that, or he must have, I believe, probably passed away before chaos theory came into full bloom, because chaos theory is intricately tied to nature and the shapes of the leaves and the way nature does, you know, lots of things. And snowflakes, an example, is very interesting. I'm sure you'll be able to, you know, Google up a whole ton of interesting stuff. But yeah, it is based on an infinite procedure, and procedures they go on forever. Yeah, so it does pop up in nature. Infinity does pop up in nature. Sorry. So he must have passed away before chaos theory really bloomed into the theory it is today. Yeah, there's not a basis for rational thought. That's definitely true. I mean, if you think about it for too long, you will end up not a very rational person. Huh. See, yeah, perfect example there. I mean, thinking of this infinity question too long, we start losing the ability to speak properly. Okay, and just watch the rest of the video here. Sorry about that. Okay, it's a good definition of an actual infinite and a potential infinite. You just gave there with your set notation talk. It just reminded me of a good illustrative example of an actual infinite. Well, if you have an actual infinite, like I said before, is a set. It is the set of, say, the natural numbers. It's the easiest one to think about. 1, 2, 3. You can always add another one to the set, and add another member to the set. So therefore, that set is an actual infinite. What you can do with that set, though, if you think about it, is you can say, okay, I'm going to make a new set, and I'm going to have it contain just the odd numbers. You know, like 1, 3, 5, rah rah, and you can always, because you can always add another odd number to the end of the line, that set itself is also an actual infinite. And so that's it's not the clearest way to define an actual infinite, but it's an interesting property that an actual infinite has. And yeah, of course, your potential infinite is something that, well, approaches, it always gets bigger and bigger and bigger, but never reaches where it's going, because where it's going is not real. It's like sailing towards the horizon, and the horizon, oh, I'm here, oh, but no, the horizon's over there now. It's exactly the same thing as an infinite trying. You could imagine if you're on that number counting, and you look up, and infinity is that horizon that you're never going to see, no matter how far and how long you go for. Okay, I'll just watch the rest here.